Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is section 7.6, and it's about permutations, combinations, and probability. So, we mentioned before that uh, to find the probability of an event E, we divide the number of ways in which E can occurs by the number of the elements in the sample space, all possible outcomes of the experiment. So number of elements in the event over the number of elements in the sample space. Let us look to this example. A psychologist claims that she can teach 4-year-old children to spell 3-letter words. So words consisting of 3 letters very quickly. To teach, to test her, one of her students was given cards with the letters A, C, D, K, and T. How many letters are these? 5 letters. So cards with these 5 letters were given to the students and then told to spell the word cat. What would happen to spell the word cat? The student will select first the C, then A, then T. The question, what is the probability that the child will spell cat by chance? So if we call spell cat by chance, if we call it the event E, so now we are asked to find probability of E if this event is E. To find the probability of E, we need to find the number of elements in E over the number of elements in the sample space. The sample space of the experiment. So what is the experiment? Well, for the experiment, I have 5 letters and I need to choose 3 letters of them. Are these 3 letters we are going to choose in order or not in order? Of course, in order because we need to form the word cat. So we have to choose C first, then A, then T. So choosing 3 letters out of 5 in order, the number of ways to choose 5 letters out of 5 with order is 5p3. So select K first, then T, then A. This is one choice, and so on. Now, what about the event E? Well, there is only one possibility that the word cat is chosen. C, then A, then T. So the number of elements in E is only 1. And if you use the calculator to find 5p3, the answer is 60. So it is 1 over 60. So that's the answer, the probability. Suppose that a state issues license plates with 3 letters followed by 3 digits. Let me think of the problem carefully. 3 letters, then 3 digits. 12 3-letter words are that are not permitted on license plates. Okay. So there are 12 3-letter words not permitted. So for example, CBA is not permitted. Okay. For example, 12 words are not permitted. If all possible plates are produced, what are all possible plates? That consists of 3 letters followed by 3 digits. what are the number of possible plates, number of elements in the sample space? 26 letters times 26 times 26, 3 times. Then digits, there are 10 digits. So these are the number of all possible plates. And a plate is selected at random. What is the probability that the plate is unacceptable and will not be issued? If we call this E, now let us ask ourselves, how many elements in E? How many of the plates are unacceptable? Well, whenever we have the 12 words, the plate will be not acceptable. So there are 12 words, 12 words. But the digits could be anything. So 12 words with any digits. These 12 words will not be permitted. So times 10 to the power 3. So these are the plates that are unacceptable. 12 words times any digits. So probability of E would be 12 times 10 to the power 3 over 26 to the power 3 times 10 to the power 3, or just 12 over 26 to the power 3. If three wires, red, black, and white, are randomly attached to three-way switch, the switch accepts three wires, for example. The switch has three poles, and in to which for each pole there is a wire attached, and what is the probability that the wires will be attached at random in the one order that makes the switch work properly. If you call this event E, that the wires attached at random in the one order that makes the switch work properly, let us talk about the number of elements in E and the number of elements in the sample space. Let us think of the sample space first. What is the experiment? We will attach the three wires to the three poles. Maybe we attach the red here and the black here and the white here. Now, will it work? Okay, or not? So how many possibilities are there? Well, I have three poles. In the first pool, I can attach any of the three wires. But in the second pool, I can attach the two left because one already attached here. And the last pool, there will be one wire remained. So how many possibilities? 3 times 2, there are 6 possibilities. And the one order that makes the switch work properly is just 1. So the probability would be 1 over 6. We need to read the question carefully, try to understand the experiment. That's always the case. There is no quick way to solve these kinds of questions. Suppose that of the 20 prospective jurors for a trial, so there are 12 jurors, 11 of them favor the death penalty, 9 do not. Okay, so these are the jurors. They are divided into two parts, 11 and 9. 11 favor, 9 not favor. 12 jurors are chosen at random. Okay, we are going to choose 12 out of 20. What's the probability that 7 of the jurors will favor the death penalty? So 7 of the jurors will favor the death penalty. Let me call it E. And the probability of E would be number of elements in E over the number of elements in the sample space. Well, the sample space. What is the experiment? The experiment is selecting 12 jurors out of 20. Okay, and there is no order. The 12 jurors, there is no difference between them. Uh, okay, no arrangement for these 12. So 20C12. This is the number of ways to select 12 out of 20. Okay, now we need a specific event. What is this event? We need 7 of the jurors favor the death penalty. So from the 11 who favors the death penalty, we need to choose 7 and times the two steps. Uh, how many left? 9. How many to choose from the 9? We need to choose 12. 7 favors, so 5 will not favor the death penalty. So this would be the probability of this event E. We studied number of ways of such experiments in the previous uh, section, in the previous section 7.5. So please refer to that section before coming here. If 5 people are chosen from a group that contains 4 men and 6 women, okay, we have 4 men, 6 women. We need to choose 5 out of these. How many people? 10. We need to choose 5 of them. What is the probability that 3 men and 2 women will be chosen? This is the event we need to find its probability. Probability of E would be, what is the sample space? We are choosing 5 out of 10. So 10C5. The event, I need 3 men out of what? Out of 4. So 4C3 times, how many women are there? 6. I need to select how many of them? 2. So that's the probability. A manufacturing process for computer chips is such that 5 out of 100 chips are defective. So if I have 100 chips, 5 of them are defectives and 95 are good. 10 chips are chosen at random. So we are selecting 10 chips from 100 newly manufactured chips. What is the probability that none of the chips will be defective? So if we call this event E, what is the probability of E? We are selecting how many? 10 out of what? Of 100. So 100C10 will give you the number of elements in the sample space. Now what do you need? None of the chips will be defective. So you need to choose the 10 out of what? Of the 95. And from the 5 defective, you need to choose 0. None of the defectives should be there. So this is the answer, the probability. In case of part B, if we call this event F, okay, this is E, what what is the probability that 8 will be good and 2 will be defective? Okay, again we are selecting 10 out of 100, but now from the 95 I need to select how many? 8 good. And from the defective I need to select how many? 2. Notice that always 95 plus 5 is 100, 8 plus 2 is 10. So whenever you use this probability, this is a distribution called the hypergeometric distribution, by the way. Always when you add this number to this number, 95, you get this number here, and 10 plus 0, you get 10 here. So make sure that that's always the case, not to make mistakes. 4 plus 6 is 10, 3 plus 2 is 5. It's always like this with the hypergeometric distribution. License plates. Suppose that all license plates in a state have 3 letters, then 3 digits. Okay. 3 letters, then 3 digits. If a plate is chosen at random, what's the probability that all 3 letters and all 3 numbers on the plate will be different? So this is the event I need to find its probability. And probability of E would be. Let us talk about the sample space in general. I have the total number of plates, 26 to the power 3, 3 letters, times 10 to the power 3. This is the number of possible digits. Okay, so this is the number of all possible plates. Now, what is the event? All three letters should be different. So if the first letter has 26 possibility, the second is 25, the third is 24. Or I can say 26p3 times the digits different, so 10 times 9 times 8, and this will give you the probability of this event. An automatic teller machine requires that each customer enter a four-digit personal identification number. So there is a number consists of four digits. When he or she inserts a bank card, if a person finds a bank card and guesses at a PIN to use the card fraudulently, what is the probability that the person will succeed on attempt? So this is the event we need to find its probability. So what is the sample space? I will guess the four numbers, the pen. So how many possible numbers are there? Four digits. So for the first digit, I have 10 possibilities, 10 possibilities. So it's 10 to the power 4, 10 to the power 4. And what is the probability that he will succeed in one attempt? So he immediately tries the correct choice. So that's 1 over 10 to the power 4. If the person knows that the pin will not have any digit repeated, okay, what's the probability that the person will succeed in guessing in one attempt this time? Well, the difference here, that's no repetition. So the first, if the first number has 10 choices, it's the same, but now the second number 9 choices because there is no repetition. Times 8 times 7, and again he needs to guess it in one attempt. If the first digit of a 7-digit phone number cannot be 0 or 1, so there are 7 digits: 1, 2, 4, 6, 7. The first digit could be 0 or 1, so how many choices are there? Two choices: 0 or 1. Two choices. Let me write here 0 or 1. 0 or 1. Okay. What is the probability that a number chosen at random will have the 7 digits the same? Well, this is the event. What is the meaning of this? All 7 digits the same. So, oh, the first digit cannot be 0 and 1. Cannot be. So it can be what? The first digit can be what? Can be 2. So we have all the digits, all the 7 digits 2, or 3, or 4, up to what? Up to 9. How many possibilities are these? 8. Okay. So probability of E would be 8. 8, we will have 8 possibilities when all 7 digits are the same because 0, 1 are not here. The first digit cannot be 0 or 1. Okay, what is the number of elements in the sample space? The first digit, I have two choices, but after that, I have 10 for each digit. I have 6 remaining digits. So here this is not 2, sorry. It is 8 because 0, 1 are not there and we already have 10 digits. So the possible digits for the first place is 8. So 8 times 10 to the power 6. So the answer would be 1 over 10 to the power 6 when we cancel 8 with 8. As a reward for a record year, the ACE software company is randomly selecting 4 people from its 500 employees for a free trip to Hawaii, but it will not pay for a traveling companion. Okay, so the person will win alone, he cannot bring anyone else. John and Jill are married and both are employees. What employees in the company? So they have the possibility to be picked among these four. What's the probability that they will both win? So this is the event E. And now we need John and Jill be selected among these four. So let me say that I have 500 employees. Two of them are John and Jill. And the remaining employees are 498. And I need to select 4 out of 500. But I need to select Jill and John. So from 498 employees, I need to select only 2. And I need to select John and Jill. So this will give you the probability that they will both win. In a 10 question matching test with 10 possible answers, so 10 questions and 10 answers to match. No answer used more than once. So if you pick this answer, you cannot use it again. What is the probability of guessing and getting every answer correct? Okay. So guessing and getting every answer correct, let us call it E, and let us find the probability of E. And let us talk about the sample space. What is the experiment? I am answering the 10 questions. Okay, let us answer the first question. Question 1. In how many ways can you answer the first question? Well, I have 10 answers to choose from. So it's 10. Okay, times. Uh, no answer used more than once. Okay, so now the second question. How many answers are possible? Well, only 9 because one answer has been selected for question 1. Okay, 8, 7, up to what? Up to 1. So it is what? It is 10 factorial, or it is 10p10. We are selecting 10 from 10 with order because we're answering question by question. Okay, what's the probability of guessing? Well, guessing and every answer correct, this is only one answer. There is only one possibility for this. So the answer is 1 over 10 factorial. A box of 12 batteries has 3 defective ones. Okay, so 12 batteries, 9 are good and 3 are defective. If 2 batteries are drawn from the box together, so we will select 2 out of the 12. What's the probability that both are defective? So if we call this event E, probability of E would be, I have 12 batteries and I need to select 2 of them. But now E says, what is E? Both are defective. So from the 9 batteries, I will select 0. And from the 3 defectives, I'm going to select 2. So this will give you the probability that both are defectives. What about if we call this F? Neither one is defective. So this is always the sample space, but now from the 10, neither is defective. So the 2 are good. So 9C2 times 3C0 in this case. I'm selecting 2 and neither is defective. So no one is defective. So the 2 from the good. You can find the answer. One is defective means if we call it G, for example, then one is defective and one is not. So I'm selecting one from the 9 and one from the 3. Okay, and you can answer uh, this question by in using a tree diagram if you like. You can use a tree diagram like I think in section 7.3 we discussed tree diagram, because we are selecting two uh, batteries, and the first one could be defective, the second one could or good. That's the first one. Probability of defective, we have three defectives, so 3 over 12, and this is 9 over 12. And then the second ball could be defective or good, and here defective or good. And now since we selected one, okay, one of the defectives, the number of defectives now is 2, and here the number of good is still 9, and the number of batteries to choose from are 11, because this is the second battery. You are selecting two batteries of them. Here, if one is good, so the number of good will be 11, and we still have 3 here. So if you find this answer by the calculator, 9C0 times 3C2, this is in fact 3, and 12C2 is 66. So this is 3 over 66. Uh, both are defective. This will, you will get it by multiplying uh, 3 over 12 times 2 over by 11. Both are defective, so we need D and D. So from the tree diagram, the probability would be 3 over 12 times 2 over 11, and this will give you 3 times 2, 6, and 11 times 12 is 132, and you have the same answer. In fact, it is 1 over 22, and this is 1 over 22. Okay, so you can solve this question by the tree diagram. It's a nice exercise for you. You can continue find B and C also using the tree diagram, or you use this method. A retailer purchases 100 of a new brand of DVD players, of which 2 are defective. Okay, so 100. So I have 98 good and 2 are defective. The purchase agreement says that if he tests 5 chosen at random, so he's going to select 5 of these 100, test these 5. If he finds one or more defective, okay, so if he finds one defective or two defectives or three defectives or four defectives or five defectives, one or more, then then what will happen? He receives all the DVD players free of charge. What's the probability that he will not have to pay? So he will receive them free of charge. So if we call this E, the question, what is the probability of E? Well, what is the sample space? He is selecting 5 out of 100. So 100 C5. But now he will uh, get the DVDs free of charge if he finds one or more defectives. So the probability of one or more defectives is equal to 1 minus probability of 0 defectives. Okay, because it's still the only possible thing left is 0 defectives. So probability of all of this would be 1 minus probability, I write it like this, probability of E would be 1 minus probability of 0 defectives. And 0 defectives, from the 98 goods, I select the 5, and from the 2, I select 0. So the answer would be 1 minus 98C5 over 108C5. 2C0, by the way, is just 1. A car dealer has 12 different cars that he would like to display, but he has room to display only 5. Okay, he has 12 cars and he wants to display only 5 of them. In how many ways can he pick 5 cars to display? Well, 12C5. Okay, that's the number. And you can use the calculator to find it if you like. 795. 792. Now, part B, suppose 8 of the cars are the same color. So now these 12 cars are divided. 8 of them uh, have the same color, with the remaining 4 having distinct colors. Okay, distinct colors. If the dealer tells a salesperson to display any 5 cars, so any 5 cars, what is the probability that all 5 will be the same color? So probability of E, where E means all 5 will have the same color, is now 792 is the sample space, the number of elements in the sample space, selecting 5 of 12. But now we need a specific event. We need what? All 5 are from the same color. So we need to select 5 from the 8. Okay. And from the 4, we select 0. So this would give you the probability, and this is the end of the section. Hope you enjoyed probability and chapter 7 in general.